Assalamualaikum and good morning. Today we are going to proceed to one more isomerism, which is functional group isomerism. Functional group isomerism. Functional group isomers. Functional group isomers. It have the same molecular formula, but different functional group. Okay, when it is different functional group, it means that they belong to different homologous series. For example, alcohol is different than ether. Carboxylic acid is different than ester. Okay, so different class of compound. So it have both different chemical and physical properties. What is chemical properties? As I told you earlier, if you still remember, chemical properties is chemical reaction, halogenation, free radical substitution. That is chemical reaction. Physical properties, it relate to boiling point, melting point, solubility. Okay, so that is about physical properties. Classes of compound that exhibit functional group isomerism. Okay, this is very specific. Okay, for example, this one. If you have CnH2n plus 2, this one is alcohol and ether. What is CnH2n plus 2? Let's say when we have n equals to 3. When n equals to 3. So n equals to 3, it means that you have C3H2n6 plus 2 is 8. So it means that if you see this molecular formula C3H8O, this one belong to the functional group isomer of alcohol and ether. Okay, the same thing for this one. Let's say this one CN H2NO, so N, let's say, still equals to 3. So this one is C3H2N is 6 and O. Okay, so you can see that if you see CnH2NO, C3H6O, maybe C4H8O, this belong to aldehyde and ketone. So you need to be very careful for this one. Even though this one looks very similar, C3H6O, C3H8O, the differences is just 2 hydrogen here. And it belongs to different group already. This one belongs to alcohol and ether, this one belongs to aldehyde and ketone. So you need to be very careful. You need to pay attention to detail. The carboxylic acid and ester. So this one, let's say we are still using and n equals to 3. So this one will be C3H6O2. Okay, 6 is from the 2n. 3 here is from this n. When n equals to 3. So this one belongs to carboxylic acid and ester. When you find a general formula or molecular formula CnH2nO2, so it should belong to functional group isomerism of carboxylic acid and ester. You can draw carboxylic acid or you can also draw ester with the same molecular formula. And the same thing for this one. We are still using the same thing, n equals to 3. So C3H2 times 3 is 6. Okay, so this one, it can be alkene, carbon-carbon double bond, and cycloalkane. Cycloalkane is cyclic single bond molecule. Okay, cycloalkane. Alkane is single bond. All are single bond, but it is in cyclic form. Okay, next. Let's look at example. Okay, molecular formula C2H6O. Okay, this one fit for Cn. Okay, C, if we try to write down CnH2n plus 2O, right? Okay, when n equals to 2, n equals to 2, 2 times 2 is 4, 4 plus 2 is 6. So let's see, what group is this actually? Okay, from the previous slide, CnH2n plus 2. Okay, so this one is alcohol and ether. Okay, alcohol and ether. Okay, so let's see. Okay, so this one is alcohol and ether. So you need to always refer to the molecular formula. Okay, so you can write down alcohol. Alcohol, the functional group is hydroxyl, and ether is COC. Okay, so you can write down C2, CH2, CH3, CH2OH. Okay, there are 2 carbon. Is it correct? 2 carbon, C2. Hydrogen, there are 6, 3, 5, 6. Okay, so molecular formula is C2H6. Okay, so that is ethanol. Next one, ether. This one is ether. Okay, ether. So the functional group is like this. So CH3 and CH3. So let's count the carbon. Carbon 1, 2. Okay, so correct. C2, H6, 3 plus 3, 6. So correct. And oxygen 1, also correct. And this one is dimethyl ether. So that is what it means functional group isomerism. You have same general formula but totally different functional group. Okay, this one do not be confused with positional isomer. Positional isomer, different position of functional group, but still the same group. But this one totally different group, different class of compound. This is ethanol, this is alcohol, and this is ether, which is different. It differs in chemical properties. The reaction is different between these two. The reaction is different. Alcohol react differently with ether. And dimethyl ether also have different chemical properties, physical properties with ethanol. Okay, if you look more in terms of physical properties, this one it have hydrogen bond, whereby this one does not have hydrogen bond. So physical properties is different. Okay, next one, C3H6O. Okay, this one if we try to write down CnH2nO. Okay, so what is it? CnH2nO. So let's refer to the next slide, previous slide. Okay, CnH2nO. Okay, so this one is aldehyde and ketone. Okay, CnH2nO. Aldehyde and ketone. Aldehyde and ketone. Okay, so this one is aldehyde and ketone. Okay, so aldehyde, if you still remember, it is RCOH. This is the functional group, carbonyl. This is the functional group, carbonyl. But the structure must look like this. And this one RC double bond O R. Okay, this is for ketone, but the functional group still CO. So let's see for this one. Okay, for aldehyde, this one is for aldehyde. So one carbon you already use. So you can put 2 more carbon on this side. Okay, so this is aldehyde, which is propanol. And this one is still propanol, but we can change this one. We can put this one to this part. Okay, because this one is R. We need to have R for ketone. We need to have both side is R. What is R? R is alkyl chain. What is alkyl chain? Alkyl chain, it can be distinct, methyl, it can be ethyl, propyl, and so on. So, okay, as you can see, we transferred to there. So, it must have 3 carbon. So, 1, 2, 3 carbon. Okay, correct. Hydrogen 6. 3 plus 3, 6, correct. And oxygen 1. Okay, so oxygen 1. This one, is it the same? 1, 2, 3 carbon, correct. Hydrogen, is it 6? 3, 5, 6, correct. And oxygen 1. Okay, so also correct. So the functional group isomerism, it can be for aldehyde and ketone when it have the molecular formula with this general formula. And this one is propanol. Still 3 carbon, still 6 hydrogen, but totally different group, totally different chemical properties, totally different physical properties. Molecular formula for this one, C3H6O2. Okay, this one when there are 2 oxygen, usually it can be a carboxylic acid and ester. So let's see for this one, carboxylic acid and ester. So carboxylic acid, this is the functional group, COOH. COOH. So how many carbon you already use? 2. 1. Okay. So that leave you 2 carbon that you can write down here. You can write down 2 more carbon here. Okay, so 2 more carbon. So let's calculate. 1, 2, 3. So 3 carbon, correct. Hydrogen, 3, 5, 6. Okay, correct. Oxygen, 2. 1, 2. Okay, also correct. Okay, so this is propanoic acid because it is 3 carbon. 3 carbon, if you remember, methyl, ethyl, propyl. So 1 carbon, 2 carbon, 3 carbon. So 3 carbon is propanoic acid. So ester, this is the functional group for ester. If I write down like this, R, C, O, O, R. So at this side, it must be R, alkyl. This side, it also must be R. Okay, R and R. So you already use 1 carbon. So this part must put one more. You must put 1 carbon here and also 1 carbon here because you only have 3 carbon. So this is 1 R. Okay, it must be R. R is alkyl. So this is methyl and 1 more R here. So that is valid for ester. And the name for this one is methyl ethanoate. Okay, let's try to test yourself. Write the structural formula for functional group isomer with the molecular formula. Okay, C4H8O. So this is CnH2n O without the plus 2. Okay, because 2 times 4 is 8. So this one, it can be for aldehyde and ketone, right? Okay, so for you to test yourself, pause this video and try to write down the functional group isomer for this compound. Okay, you can pause now. Okay, next. So aldehyde and ketone. So 4 carbon. So you already use 1 carbon. So at this part, you can put 3 more carbon. Okay, 3 more carbon. 1, 2, 3 carbon. So this is 1, 2, 3, 4. So correct. Hydrogen 8, 3, 5, 6, 7, 8. Okay, correct. And oxygen, there is 1 oxygen. Okay, so butanol. And for the ketone, remember ketone, RCOR. So both side here must have carbon. So carbon and this one. Make sure it is 4 carbon. So butanol for this one. Okay, this one C6H12, CnH2n. Okay, so for C6H12, which follows CnH2n, this one, it can be, if you remember, alkene and also cycloalkane. Okay, so let's try to draw for this one. It should have alkene, which is double bond. Okay, you can change this one into skeletal form like this. Okay, so how many carbon? 1, 2, 3, 4, 5, 6. So you can put double bond here for the 6 carbon atom. You can also transfer the double bond, maybe between carbon number 2 and 3, number 2 and 3. Okay, so it will be like this. Or you can change the double bond to carbon 3 and 4. Okay, this is 3 and 4. But can you change it into carbon 4 and 5? Okay, you can, but actually when you transfer this one into carbon 4 and 5, the double bond, it actually the same with this one. Okay, you just flip. Okay, you just flip the image and it will be the structure number 2. Okay, let's label. This is structure 1, structure 2, structure 3. Okay, if you have double bond between carbon 4 and carbon 5, this one actually will become structure number 2. Okay, so it's similar. It is not isomer. But what we are looking for is not positional isomer. All these 3 is positional isomer. Compound 1, compound 2, compound 3 is positional isomer. But we are not going to write down like that. You need to write down 1 and 2 like this, positional isomer. Okay, 2 and 3 also positional isomer. 2 and 3 also positional isomer. The same with 1 and 3. 1 and 3 also positional isomer. But we are not looking at the positional isomer. We are looking at the functional group isomerism. So the functional group isomer for C6H12 is one more, which is cyclic compound, cyclic alkane. So 1, 2, 3, 4, 5, 6. So there are 6 carbon. this carbon here have already 2 bond. So what's left for you is 2 more bond to be bonded with H, because carbon should always have 4 bonding. Okay, so at each end here we'll have 2 hydrogen, because we want to calculate how many hydrogen are actually there. Okay, so C6H12. So let's calculate the carbon. 1 2 3 4 5 6 7 8 8 8 9 10. One more. 1 2 3 4 5 6 7 8 9 10 11 12. Okay, so 12. So 12 carbon. So it is valid for this one and also valid for each of this. Okay, so that one is functional group isomer. Compound 1 and compound 4 is functional group isomer. Compound 2 and compound 4 is functional group isomer. Compound 3 and compound 4 is functional group isomer. But 1 and 2 is positional isomer. 2 and 3 also positional isomer. And 1 and 3 also positional isomer. Okay, so that's it for today. I hope you are able to understand what is functional group isomerism and all the isomerism that we have learned earlier, which is chain isomer, positional isomer, and this one functional group isomerism. So that's all. Good luck.